Okay, so we're looking at tutorial 3 and part 11. And so we're asked for the Vickers hardness if the diagonal length of an indent was found to be 2 by 10 to the minus 4 meters under a force of 100 newtons. Okay, so let me explain a little bit about what this is. So Vickers hardness is a method of testing hardness whereby we have a diamond indenter which always has an angle here, 136 degrees. Okay. We then apply this with some force into the surface of our material. That indents it. And then after the indent, we raise the indenter back up again. And we look using a microscope down at the sample. This is an eye here. And what you'll see at that stage is you'll see an indent of a diamond shape on the surface. Okay. We can then measure the length of these diagonals using the microscope. And usually what we do is we'll take an average of those. To get the dimensions of that in order to calculate the area. Okay. So, you know, you would expect D1 to be equal to D2, but sometimes your sample is just a little bit uneven and they won't quite be. Okay. So we calculate then the hardness of the sample is equal to force over area. Okay, so similar to what you'd be used to. Now there are two different ways we can calculate this. We can use the SI units, which, you know, force in newtons, area in meters squared will give us pascals, megapascals, or gigapascals. Or we can use the archaic system, which is the Vickers hardness system. And I'll talk a little bit about that in a minute, okay? So the force here is relatively easy. We've been given it. That's 100 newtons. Now you might think that area is relatively easy because you can just take D1 by D2, but of course that's the two-dimensional area. So to get the three-dimensional area of the indenter, it's a little bit more difficult, okay? So we use an equation for this. I'm not going to go into the derivation of this. You don't need to know it. Okay, so that's d squared divided by 2 sine 136 degrees divided by 2. And that roughly comes out to a simplification of d squared divided by 1.8544. Okay, so we can use that then to calculate our area under the indenture. So if we just have a look at the SI version first, we'll change color here. So note this area is true for both the SI and the archaic system. You will usually be asked the SI. So in this case, for the SI, obviously we have only newtons. So we're going to take this here. Divided by area. And our area would come out as, was our diagonal given 2 by 10 to the minus 4 meters. That's going to be squared all over 1.8 by 4. Okay. So that comes out as 2.157 by 10 to the minus 8 meters squared. Okay, so then we can calculate our hardness. Is equal to 100 newtons divided by 2.157 by 10 to the minus 8 meters squared. So that's going to give us 4.64 by 10 to the 9 newtons per meter squared. Okay, which is equal to 4.64 gigapascals. Okay, this this is equal to a Pascal. Okay, and 10 to the 9 is a giga. Okay, so that's relatively simple. Our SI version. Now let's look at our Vickers hardness archaic version. Okay, let's just call this HB. Okay, so Vickers hardness uses a thing called kilogram force, which is equal to the force exerted by 1 kilogram, which is pretty close to the SI, and because obviously convert that to newtons, you're going to multiply by 9.81 meters per second squared, acceleration due to gravity, to give you newtons. So it's not going to be far off in terms of the actual number. Okay, so if we take 100 newtons, that's going to be equal to 10 kilogram force. Okay, roughly. So we'll just divide it by 10, which would be related to this. Okay. Now, the archaic system of Vickers hardness also relies on millimeters rather than meters. Okay. So we need to calculate our area here in terms of millimeters. The area is equal to, in this case, 0.2 millimeters squared divided by 1.8544. So if we convert this meters into millimeters, it comes out as 0.2 millimeters, okay, which is where we've gotten this. So that works out then as 0.02157 millimeters squared. So then we can put that back into our hardness equation, which is still true. So hardness is equal to 10 kilograms force divided by 0.02157 millimeters squared, which comes out as 463.5. The units here are called HV, Vickers hardness. Okay. And we usually put a little slash and then the number of the kilogram force. Okay. So that is the archaic system. But as I said, usually you will be asked for the SI units.